So I guess without further ado, we can jump in and kind of tackle right away, kind of like the main question, right? So we talked a little bit about just the challenges of how do you even approach any machine learning problem? There's so many moving parts. And, you know, for those of us who work in the industry know it's like very different than what you see on like a Kaggle competition where you have a clean data set and the metrics figured out for you. So I'd love to hear from you guys. How do you start the research process? Like, what do you do when you start tackling a new problem?
Okay, maybe I'll take a stab at it.
Sure, yeah.
There are two parts, I guess, to this, right? One is the research problem in itself and kind of coming up with the problem definition. And on top of that, if you're working in the industry, you have the added issue of putting it in production. And the production puts a significant constraint on what kind of research that you can do, right? So I guess one of the ways is to kind of define the problem and kind of define the system that you're going to build. And if you're going to put something in production, I would strongly recommend to build out the system first and maybe start off with simpler models because it makes things just simpler in the long run. Debugging and maintenance and these things are simpler to begin with. So I try to keep things simple and try to build out pipelines so that, you know, once these things are built, then we can start rapidly iterating on the model. Because these models these days require a lot of data. And then most of the times, the models that you build, the loss that you have is not exactly what you care about. Like apart from some classification problems and such, right? Even if you build a ranking problem where you typically use pairwise loss, but that's not really what you care about. So, you know, having a strong evaluation framework as well makes a lot of sense because then you can start, you know, adding complexity to your model and figure out whether that's kind of making sense with your final task.
Yeah, definitely. That makes a lot of sense. And I think, you know, your point about thinking about production and kind of the constraints that puts on you definitely makes sense. I have a few follow-ups on that, but I want to see what Pierre and Victor has to share about this. How do you guys start your research process? Do you follow a specific process? There's a certain order that you follow? How do you like looking at these problems?
Maybe I can go. I can say that it really depends if the kind of project that I'm working on is an applied project or a purely research project. Because for the purely applied projects, in many cases, at least in my experience so far, has been that the kind of data that I'm working on, I'm the only one, or I mean, in the organization that I'm working in, is the only one who has access to the data. And there's usually not much, you know, historical progress that happened on that data. While for a research problem, if it's something that other people worked on in the past, well, there's like a lot of maybe papers about that. So if I'm starting from a research perspective, I usually study what's there. That's really the number one thing that I do. But when the project is more applied, what I usually do is I take the data and look at it. That's really number one thing, trying to understand what's going on, trying to understand if, at least if there's signal for the problem that I want to solve, because I don't know, in many cases, part of the fact that a machine learning model doesn't work is that there's not enough signal to actually do any prediction from the data, right? So after looking at the data, which is again, number one thing, I personally, what I do is actually end up using the tools that I built for myself, just because it's, you know, it makes it easier for myself to actually compare different models and to have like a standard pipeline, because again, I built it once, I put it into open source, and now I can reuse it every time I want. I found it's really rare for me to find situations where I cannot reuse the stuff that I already built. And so usually I train a little simple model, try to see what is there, look at the predictions, do some visualization, understanding how the learning curves go, understand the predictions. And when I feel like I have a global understanding of both the data, the problem, and some initial simple solution, then I double down on, as also we were discussing before, like double down on maybe on more complex models and more sophisticated approaches, but starting simple first and then scaling up is really the complexity is also a really good advice.
Definitely. So yeah, that's really interesting. So it sounds like you mentioned, you kind of alluded to it, of trying to see if there's enough signal in the data. So do you typically, in the applied settings, do you typically make a go, no go decision on it? Or certain scenarios where maybe there's a business KPI or a requirement to try to build something, but then you kind of look at the data or try to fit it in certain ways and you realize that's not feasible?
Yeah, so it's interesting because I believe, and again, I'm not the only one, I guess, that machine learning projects are much closer to research projects than software projects for this specific reason. Because a software project, usually you define some constraints and you just go and implement them. You don't have like the question if it's ever going to work or not. In the case of a machine learning problem, beforehand, you have an hard time knowing exactly if the problem is solvable to begin with. And so that's the reason try like simple solutions first, and in case fail fast and figure out fast that you don't have enough signal for solving this problem. Otherwise, you enter like a process of maybe even really long, where you spend a lot of time beforehand, and then you end up with having a model that doesn't like get the performance that you have actually set as a bar to begin with, right? So an iterative process where you fail fast and you figure out early if you're going to continue or not. It's really needed for machine learning projects, in my opinion.
Definitely, yeah. I think you and Ambarish are sharing similar things. Starting simple, fail fast. Definitely make a lot of sense and very common with kind of what we hear with our customers working on a diverse set of problems. Victor, you're on a slight different take, I would say, because I think a lot of your project has, I would say, a more machine learning engineer or even a software engineering component to them than kind of pure research. How do you approach a new problem? What's your process?
I would say that it's like really loose because I basically have like this spreadsheet with a lot of random ideas that come along, and like with my readings and like talking with other people, and I just pick the one that excites me the most. And that's really how I choose my projects. But like I definitely agree with Piero and Barish, like you want to start really fast and iterate fast at the beginning. Like don't really look at like how well you code, but you want to experiment fast and like understand the data and like the learning processes, the learning methods really quickly, so that you can decide like, is it worth it to pursue that for like a couple of weeks? And like I would say like the 2 very first weeks are like really decisive, because that's when like you actually get a sense of like your data and the distributions, and like actually is there any improvement you can actually do here.